Let's look at this simplification problem of the composition of inverse sine and sine x when x is not in the domain, the principal domain of sine x, or the range of this inverse of sine. The fact we're going to use is the following. This is the fact that we need to use, or this is about the property of inverse function and the function itself, that if this x is inside this interval, negative pi over 2 and pi over 2, if this is inside over here, some point over here, then this is true. Then we have sine inverse and sine x is simply equal to x. But this identity isn't true if x is outside, because we know the range of sine inverse can only be between negative pi over 2 to pi over 2. So, for example, if x is between pi and 3 pi over 2, then this isn't true. So what is the idea we're going to use over here? The idea is the following. So, if x is not inside this interval, negative pi over 2, 2 pi over 2, then we need to find another point. We say x star over here. This point over here is inside this negative pi over 2 and pi over 2, such that this is true, such that these two values are the same, such that sine x is equal to sine x star. Now this is always possible because sine x is between negative 1 and 1. So once this is done, then we have the following. Then we see that sine inverse of sine x is going to be equal to sine inverse. This is the same value as sine x star. Now x star is within this interval, so this one is going to be x star. Right? So if we draw a diagram, this can be actually seen quite clearly. This is an example. Let's look at this example over here. Try to find sine inverse of sine 3 pi over 2. Let's draw a diagram to see how this can actually be done. So this is what we have, the sine function over here. Right, this is what we have. Okay, and this point over here is 3 pi over 2. Now, we look at this value over here and try to find another place, but within the range of pi over 2 to negative pi over 2. So they have the same value, and we can see, of course, here is the same value, and this is only 1. So we can see over here that x over here is 3 pi over 2, which is outside of this interval. And we see that sine x over here is negative 1. And we find a point over here inside this interval over here. So that value is going to be negative 1. X star now is going to be inside negative pi over 2 and pi over 2. And this sine x star should be equal to negative 1. There's only one choice. X star must be negative pi over 2. Now we have the conclusion over here that sine inverse of sine 3 pi over 2 is equal to sine inverse and here is sine negative pi over 2, and then the value is going to be negative pi over 2. This is one. Let's try another example over here. Let's try this sine inverse and sine 5 pi over 4. Okay. If we look at where this point is, it's somewhere over here. It's somewhere over here. This is going to be 5 pi over 4. Okay. And if we look for a point within this interval, so the value is going to be the same, it's over here. So this is the one we have over here. Because you see over here, they have the same value, right? And we can actually see over here, sine 5 pi over 4 is going to be equal to sine negative pi over 4. So again, we have sine inverse of sine 5 pi over 4 is going to be equal to simply negative pi over 4. Now, let's make this x to be a little bit more general value. So we're going to look at this one over here. X is between pi and 3 pi over 2. So now x is somewhere between pi and 3 pi over 2. So within this interval over here. Now this is beyond negative pi over 2 and pi over 2. Now if you look at what we have over here, somewhere over here, but the relationship we use over here is this one. Sine x is going to be equal to sine pi minus x. This is in fact an identity because we can easily see from the graph that sine x minus pi is negative sine x. Now we may ask why you use this identity, where this identity is from. Well, we somehow look at the graph, we observe, and we make an educated guess, and we verify. So if you look at how you can get these values over here, you will see that if your x is somewhere over here, okay, and the corresponding value over here is going to be pi minus x. If x is 3 pi over 2, then pi minus x is going to be negative pi over 2. So we look at this symmetry over here and find out this one over here. Okay. Of course, we can easily verify this with a trig identity, but on the other hand, we can easily see from its graph. And we choose this one also because pi minus x now is inside this interval. So we can see that when x is between pi and 3 pi over 2, not only this equation, this identity holds, but also this pi minus x is inside negative pi over 2 and 0. We can see that because when x is pi, it's going to be 0, 3 pi over 2 is going to be negative pi over 2. So now we have, based on these two properties over here, that we have sine inverse of sine x is equal to pi minus x if x is inside pi and 3 pi over 2.